So we're going to start with imaginary numbers. When we were in Algebra 1 and we came across a negative in the square root, we were told it's no solution. Well, there's no real solution, but we actually do have an imaginary number, I. It's the imaginary unit. I is defined as the square root of -1. We don't need lots of numbers. We just need to represent what if there's that negative under the radical. So if I have the square root of -25, that is just 5i is how we represent that answer. It can't be -5 because -5 times -5 is a +25. So the only way to have that negative and get the square root is to have this imaginary unit being multiplied in there. Okay? So when I take the square root of -25, it's 5i. If I have the square root of -81, what do you think that is? 9i. It's not super complicated. After the mid-chapter 3 test, we'll talk more about imaginary numbers and operations with them. Right now, it's just if there's a negative in the square root, we put an I on our answer. So if I have the square root of -12, well, I can't do the square root of 12, but it can be simplified. Yesterday, we said that's 4 times 3, which is 2 times 2 times 3. So that's 2, right? The pair comes out. And then we had the square root of 3. Notice I left a space because the negative means it's 2i square root 3. We like the I in front of the square root because when we put it behind it, it sometimes looks like it's inside the absolute value, and we don't like that. So we put the I in front of the square root, but behind the number. Okay, we don't like x2, we like 2x, right? We like the letters behind the numbers. Okay, and if I have, say, the square root of -6, well, I can't simplify the square root of 6. So this just comes out as I square root 6. I can leave the 6 in the square root, but I bring that negative out front to show that I know that's an imaginary answer. Okay. I don't know, this is bothering me hanging. Okay. Questions?
Why wouldn't you simplify the 6?
Because 6 is 2 times 3, which neither of those is a pair, right? So if I can simplify it, I will, but 6 doesn't have any pairs and no perfect square factors. So the square root of 6 is as small as that can go. Okay. All right, now let's talk about some equations. Say I have x squared equals 9. We know that equations are asking what number squared is 9. Aren't there 2 answers here? Yeah? What are my 2 numbers that when I square them I get 9? 3 and -3. When I square -3, don't I get +9? When I square +3, don't I get +9? So I have 2 answers. Okay, so we're always going to have 2 answers unless the square root equals a 0. So let's look at how we're going to show work on that equation. The square root undoes the square. So the square root of x squared is equal to x. So we can use that like we would divide both sides or multiply by both sides to do the inverse. We're going to take the square root, and when we take the square root of the number, we're always going to put a plus and a minus in front of it. It's both positive square root of 9 and negative square root of 9. And our answer comes out x equals plus or minus 3, which means the same thing as writing them as 2 separate numbers, but mathematicians like to be more concise. Questions so far? No? All right, so let's look at a more complicated equation. 4x squared minus 31 equals 49. We're going to solve these equations like we solved the absolute value equations. I want to get the absolute value by itself, and then I'll deal with the square. Okay? So what should I do first? Nope. I'm going to add the 31. Okay? I'm not trying to get it equal to 0 because I want to try to use the square root rather than factoring. These equations aren't going to necessarily be factorable. Some of them might, but we're trying to use the square root function to undo it, so we want to get the x squared on by itself on one side. So we have 4x squared equals 80. Now what? Divide by the 4. And we get x squared equals 20. Now the x squared's by itself, so we can take the square root of both sides. Plus or minus the square root on the other side. You always have to have the plus or minus. There are two possible answers. Okay, the positive square root of 20 and the negative square root of 20. So x is equal to plus or minus, and I need to simplify my radicals if possible. And just like we did in the homework last night, they have to be simplified. I can't have the square root in a radical, I'm sorry, I can't have a fraction inside a square root. I can't have a square root in the bottom. So I have to follow all those rules with my radicals. So how do I simplify the square root of 20? 4 times 5, which is 2 times 2, right? So that's a pair, 2 square root 5. And that's my answer. No, because it's not negative 20. The plus or minus is in front of the absolute value. If it was negative 20 in front of the square root. If the negative was inside the square root, then yes, it would be I. And I don't want a decimal approximation. Okay, we're only going to use decimals with radicals if we're talking about a word problem, because if I'm trying to know what 2 square root 5 feet are, I don't know what that is, right? So we need a decimal if it's a word problem. But any kind of just solve the equation, we want an exact square root, simplified. Okay. So here's the next one. 3x squared plus 9 equals 0. So what am I going to do first? Subtract the 9. 3x squared equals negative 9. Now we can divide by 3. X squared equals negative 3. Now what? Square root both sides. Plus or minus the square root of negative 3. The square root and the square cancel. So we get x equals plus or minus. How can I simplify the square root of negative 3? Notice the plus or minus is first. Everything I do with the square root is after that plus or minus right now. It is I square root 3. And that's my final answer. Okay, our next example. 2 times x minus 4 squared equals 98. Now, sometimes students want to FOIL this out. Oh, I see a polynomial squared. No, we're not multiplying x minus 4 times x minus 4. We're going to turn it into a problem that we don't even know how to solve yet. Because if this isn't a perfect whole number answer, it's not factorable. And we don't know how to solve them if it's not factorable. So we want to just use algebra on these. by doing inverse operations. So I want to get this x squared part by itself. So I'm going to do that by dividing by 2. So x minus 4 squared equals 49. Now I can't add the 4 because it's still in those parentheses squared, so I need to undo the square. How do I undo the square? By using the square root. Plus or minus the square root on the number. So x minus 4 equals plus or minus what? 7. The square root of 49 is 7. And now I can get x by itself by adding 4. And we're going to add the 4 inside, in front of the plus or minus. So x is 4 plus or minus 7, which means 4 plus 7, what's that? 11. And 4 minus 7, negative 3. So my two answers are 11 and negative 3. Okay. So this is a concise way to write two separate equations for two separate numbers, 4 plus 7 and 4 minus 7. So I have 2/5 times x plus 3 squared equals 5. Again, we're not foiling this out. We're just going to get rid of the coefficient by doing what? Multiply by the reciprocal, 5 over 2. So we get x plus 3 squared equals 25 over 2. To get rid of the square, we're going to take the square root, plus or minus the square root. Now yesterday we simplified this. This square root of 25 over the square root of 2, which was 5 divided by the square root of 2, right? I could take the square root of the top and the square root of the bottom. And then what? Am I allowed to have that radical in the denominator? No, so how do I get rid of it? Multiply by square root 2 over square root 2, right? And we end up with 5 square root 2 over 2, right? Because the square root 2 times square root 2 is the square root of 4, which equals 2. And the 5 is not under a radical, so I can't combine it with the 2. I can just put it in front of the radical. Now we can subtract the 3, and we're going to subtract it in front of the plus minus. X equals negative 3 plus or minus 5 square root 2 over 2. Okay, and I see a common mistake. People want to combine this 3 and the 5, but it cannot be combined separately. This 5 is attached to that square root 2. It's not the same as saying that this would be 2 square root 2 over 2. It doesn't work like that. So this is the best I can do for writing a simplified answer. Okay, questions so far? No? Yes? I could have gone straight from here to this step. Is that what you're asking?
No, because that simplifies to 5, right?
No, it's 25 divided by 2. It's 12 and a half. Right? This isn't square root of, right? So it's just 25 divided by 2. So otherwise I would have. Yeah, if it was 25 divided by 5, it would have just made it 5, and then we'd have the square root of 5, and we'd move on. No problem. Okay. What do you think I should do first here? We want to add the 8. A lot of students like to try to divide by the 5 first, but if you divide by 5 first, you have to divide the 8 by 5. Then you get fractions. And you guys don't like fractions, so don't make more fractions than you have to deal with. So move the constant, then do the division. 5 times 2x plus 3 squared equals 30. Now I can divide by that coefficient. Notice I'm not distributing because I can't distribute into the parentheses with the square on it. If it was parentheses without the square, yeah, I can distribute. But the square has to come first, and I can't do that. So we're going to go opposite operations. Well, I can do that, but I don't want to. Okay, so that's 2x plus 3 squared equals 6. Now how do I get rid of the square? Square root plus or minus the square root. So 2x plus 3 equals plus or minus the square root of 6. And we're going to subtract the 3. So 2x equals negative 3 plus or minus square root of 6. Then we can divide by 2. So x equals negative 3 plus or minus the square root of 6 divided by 2. And remember, I can't simplify when there's a number outside the radical with a number inside the radical. So I can't do anything more to this. I can't simplify it more. I could write it as 2 separate fractions, but that's unnecessary. So we'll just leave it as negative 3 plus or minus the square root of 6 divided by 2. And a lot of times when we're solving using quadratic formula, our answers come out looking like this.